Assalamu alaikum dear students. Today we'll discuss the topic functions. Before going to the topic of functions, we watch what is the relation. Why? Because function is a special type of the relation. To discuss the relation, we take an example of two sets A and B. Here the relation is the member in the set A is friend of the member in set B, which is shown with the help of these arrows. For example, Ali is friend of Yasin, and Ali is also the friend of Tahir. Yasir is friend of Zubair. Kamran is friend of Zubair, and Kamran is also friend of Ubaid. Uh, this is the relation. We take another example of the relation. Here the first set is the set of the names of the sons, and the second set is the set of the names of fathers. For example, here we watch that Albert is son of A. Bernard is son of A. Ken is son of A. A has three sons. Now, Vasi is son of B. Wasim is son of B. And Yasir is son of C. Here, Wasi and Wasim are the sons of B. And Yasir is son of C. Here you see that every element in the first set has a unique image in the set second. So this is unlike the relation as we have discussed in the first example. Over here we can say that every element in the first set has a unique image in the second set. Such a relation is named as function. So we take another example of this special type of the relation, means function, where the first set is the set of the names of the boy students, and the second set is the set of the members of the marks what they obtained in some certain test. So boy A acquires 40 marks, B acquires 70 marks, C has got 50, and D has scored 60 marks. You watch that over here, each and every element of the first set has a unique image in the other set. Members of the first set are named as domain, and the members of the second set are named as the codomain. In a certain function, the in some relation between the two sets, the first set is named as domain and the second set is named as codomain. When every element of the domain is mapped on a relation where every element in the domain has a unique image in the codomain is named as function. So this is another example of the function. So function is defined as function is a relation in which every element in the domain has a unique image in the codomain. We take some examples of the questions for better understanding. Question number 1 from exercise 5A of book 4. The statement of the question is, each of the following relations has a set of integers 2, 4, 6, 8 as its domain. State whether each of the following arrows diagrams defines a function. If the answer is no, state the reason. In part A, every element of the domain has a unique image in the codomain. 2 has unique image, 4 has unique image, that is 1. 6 has unique image, 8 has unique image, which is 2. So this is a function. A is a function. Now in part B, we watch here that this 2 has 2 images in the codomain. So this is not a function. Why? Because here 2 has not a unique image in the codomain. This has 2 images. One is A, other is B. So this part B is not a function. Now C. Here we see that each and every element of the domain has a unique image in the codomain. So this is a function. D, this is also a function because every element in the domain has a unique image in the codomain. E, here is a problem that 4 is an element in the domain which has no any image in the codomain. So this is not a function. Here in F, each element in the domain has a unique image in the codomain. So this is a function. So here B and E, these are not the functions. Rest of all are the examples of the function. To have a better understanding of the function, we take an example. Here is the function f of x is equal to 2x plus 1, and this is the domain. In the domain we have -2, -1, 0, 1 and 2. One by one we'll put the values from the domain here in place of x. When we put this -2 in place of x, what results for the member in the codomain? It results -3. So the value of function at -2 is -3. Now we calculate the value of function at -1. Putting -1 in place of x in the function, the result comes -1. So -1 maps onto -1. Putting 0 here in place of x in the function results 1. So 0 is mapped onto 1. Putting 1 in place of x in the function results 3. So 1 is mapped onto 3. Putting 2 in the function in place of x results 5. So 2 is mapped onto 5. Now we take another question. Question 3 from the same exercise. A function is defined by f at x equal to 6x minus 4 for all real values of x. What are the images of 2, -4, 1 by 2 and -1 by 2 under the function? The given function here is fx equal to 6x minus 4, and we are supposed to find out the value of function at 2. So the value of function at 2 results 8. Value of the same function at -4, this results -28. To find out the value of function at 1 over 2, putting 1 over 2 in place of x, we have calculated f at 1 by 2 results -1. Now the value of function at -1 by 2, it results -7. Now the statement of question number 5. Given the function gx equal to 7x plus 4, find the values of each of the following. In part A, g at 2. In part B, g at -3. In part C, G at 4 by 7. In part D, G at 0 plus G at minus 1. In part E, G at 1 by 7 minus G at minus 1 by 7. Now we solve it. In part A, G at 2. To find out G at 2, we have put the value of x as 2 in the function, and we have calculated 18 as a result. To find out the value of function at minus 3, G at minus 3, we have calculated minus 17. In the next part C, G at 4 by 7, putting 4 by 7 in place of x in the function, we have got G at 4 by 7 equal to 8. Now in part D, we have to find out G at 0 plus G at minus 1. This way, putting the values and solving it accordingly, it results 1. Now in the next part, we have to find out G at 1 by 7 minus G at minus 1 by 7. Now we will solve it accordingly. It results 5 minus 3 equal to 2.